Okay, question number 1. Too thick. So, logarithm 16 by base 4 is equal to. So what we need to do, we need to convert to an exponential equation. So to convert to exponential equation, we need to understand one thing, that when we have logarithm a by base b is equal c. b is base. c is exponent. So we can rewrite it in exponential form, like b raising to power c, and that will be equal a, which means b raising to power c, and that's equal a. That's exponential form. Let me write down. So my base is 4, right? Exponent is 2. So it's gonna be 4 to power 2 is equal 16. Okay, question number 2. Write in logarithmic form. So we are going now to do vice versa. We have logarithmic format, exponential format. 6 to power 2 is equal 36. Now in the format of logarithmic form, it's going to be logarithm. So this 6 is my base, right? It's coming here, 6. And the exponent is 2. 6 raised to power 2, it's equal 36. Question number 3. We have logarithm 5 over 7 by base 10. Okay, we are going to use here properties. Using properties of logarithms, we need to rewrite this expression as a sum or difference of each logarithm. Let me write down the property of logarithm. When we have logarithm a times b, that is equal logarithm a plus logarithm b. If we have logarithm a over b, that is equal logarithm a minus logarithm b, which means product of logarithm we can convert into addition, sum of logarithm, and division of logarithm we can convert into subtraction of logarithms. So since we have 5 over 5x, let me add here x, 5x over 7, so it's gonna be equal logarithm 5x by base 10 minus logarithm 7 by base 10, right? Now 5x meaning 5 times x, which means it's a product. I can break down logarithm 5 by base 10 plus logarithm x by base 10 and minus logarithm 7 by base 10. Next, we have 2 logarithm x by base 2 minus free logarithm y by base 2. Okay, let me add here next property of power. So logarithm a by to power p is equal p times logarithm a, which means this the power comes in front, right? Okay, well, let's use it. I have here 2 as a power times logarithm x. Free as a power times logarithm of y by base 2. What does that mean? That means this 2 is gonna come here as an exponent. Come here as an exponent, yes? So let's do it. So we get logarithm x by base 2 to power 2 minus logarithm y by base 2 to power 3. So from here, we have here subtraction of logarithms right here, which means we can convert into division, right? So from here, we will get logarithm at the base 2 x squared over y cubed, right? Because here we have subtraction that converted into division. One thing I need to mention, it's crucially important. You can apply all these properties only and only if bases are the same. See, bases are the same. If bases are not the same, you cannot do anything. Okay? Question number 5. Oops. So convert to an exponential equation. We have logarithm 256 by base 4 is equal 4. Okay, we are going to convert. So 4 to power 4, right, is equal to 256. There we go. 4 to power 4 is equal to 256. Question number 6. Logarithm 125 by base x is equal 3. Again, converting. Oh, here we need to solve the equation. Okay, because we have x. Here we need to solve. Okay, how are we going to solve? Using exponential form, which will be x to power 3 is equal 125. Let's write down x to power 3 is equal 125. Okay, so remember in the previous video I told you if we have base the same, let's say a to power x is equal a to power y. If base is the same, then we can insist that x is equal y. The same thing we can say about vice versa, which means if I have a to power x is equal b to power x, so which if bases are the same, then we can insist, exponents are the same, then we can insist that bases are equal also. So what I'm going to do in this case, I'm going to represent, I know 125 is a 5 to power 3. So I'm writing down x cubed is equal 5 to power 3. How are you gonna figure it out? Let's say I know that 125 is 5 to power 3. But you, on the other hand, if you don't know, you can look this way. You have here power 3, which means you have to figure out which number to power 3. It's going to be 125. Or take a radical 3, do this. Cubic radical of 125. And on calculator will come out 5, which means 5 to power 3 is equal 125. Okay? All right. So if the bases are the same, exponents are the same, then bases also are equal. X is equal 5. Okay. Here is, I missed here something. It's supposed to be negative 3. Well, let's take care of negative 3. So let me see. X to power, we have x to power negative 3 is equal 5 to power 3. I need negative 3, right? To have negative 3, because 5 is over 1. So I'm going to flip 1 over 5. Then it will be negative 3. Yes? Because every time when you want to get rid of negative exponent or you want to bring to negative exponent, you're going to flip your fraction. When we say 5, whole number, we understand 5 over 1. So if you want to represent in the format of negative exponent, you're going to flip it. 5, it's going to be 1 over 5. So from here, we see that exponents are the same. Hence, x is equal 1/5. Next, question number 7. Question number 7. We have logarithm x by base 3 is equal 3. Okay, then how do we solve this? How to find how much x will be? Very easy. Based on the exponential format, we can write down 3 to power 3 is equal x, which is x is equal 27. Next, question number 8. So logarithm by x plus 2 by base 1/2 is equal negative 3. Okay, that is equal 1/2 to power negative 3 is equal x plus 2, right? I cannot, and you also cannot, let me write down this negative 3 more clear. One thing you need to know, if you have logarithm a plus b, you never can write down log a plus log b. You cannot do that. Only you can convert into sum if you have product. Right here. Only product you can convert into addition. Okay? All right, so what do we have here? We have negative 1/2 to power negative 3. So I'm going to flip and represent in format positive 3. So 2 to power 3, right? Because 2 over 1 to power 3 is equal x plus 2. 2 to power 3 is 8, is equal x plus 2. So I'm moving 2 on this side, which will be negative. 8 minus 2, let me take this. Okay, 8 minus 2 is equal x. X is equal 6. Question number 9. Log x plus 7 for 12 is equal 1. Okay, what does that mean? X plus 7 to power 1 is equal 12, which means x plus 7 is equal 12, x is equal 5. Question number 10. 2x minus 10 is equal logarithm 1 by base x. Okay, so how I'm going to solve this one? Very easy. So first step, what we're gonna do, we're gonna represent x to power 1. Well, no, let me rewrite this so to make it easy. Logarithm 1 by base x is equal to x minus 10 for readability. That means x to power 2x minus 10 is equal 1. Yes? Okay. Can I represent 1 as x to power 0? Of course I can, because any number, anything to power 0 is 1. Equal x to power 2x minus 10. So, do I have same base? Yes. That means my exponents also are equal. So 2x minus 10 is equal 0. 2x is equal 10 and x is equal 5. Nice solution. Okay. Problem number 11. Now we are going to graph logarithmic functions. So question number 11. So we need to draw the graph f of x is equal logarithm x by base 3 plus 5. Okay. How we gonna do that? Well, first let's build. There are two ways. I can do by build at the log x by base 3 and then take this graph and move up by 5 vertically, or I can build by points. Okay? Let's see. This is my x. Here I have log x by base 3. Okay? Let's say if my x is 1, then how much will be log x by base 3? Let me see. Log, instead of x, I'm plugging 1. Here is 3, right? So 3 to what power will give me 1? 0, right? And it's going to be equal 0. Okay? Next. I can't take x is equal 0 because there is no number I raise to power will give me 0. Right? Okay. What I can do, I can take x is equal 3. If I take x is equal 3, log 3 by base 3, then it's going to be equal how much? Of Of course 1, 3 to power 1, it's going to be equal 3. What else is going to be interesting here? Let me see another point. What point I can take so to make it interesting? Trying to, what else can take? Let's take -1. No, -1, it's not gonna work. Let me see. X is equal. Logarithm by base 3. 1/3. Okay. I'm taking x 1/3. So 3 to what power is going to give me 1/3? -1, right? Because 3 to power -1, it's going to be equal 1/3. So then here we will have -1, correct? Okay, let's build this graph. So far we are building only this piece. Once we grab this, we can take this graph and move up by 5. All right. Let me clean this, make space for the graphing. So what does that mean for you? You can always take the point 1. Next point, you can take this 3 point. You can take the one that you have as a base. And lastly, third point, you can take the flip value. If it was 3, then 1/3. If this base is 8, then you take 8 and 1/8. Okay? So that's how you're gonna figure out the points, the easiest way. All right, so let's see. X is 1. This is our x. This is our y. X is equal 1. Y is equal 0, which means this is this point. By the way, just for when we were drawing exponential graph, it always would cross y in the point of 0, 1. The same way logarithm will cross at the point 1, 0. Okay? Next, x is equal 3. This is 1. This will be 2. This will be 3. This point is 3. Let me clean this 1, 0, bring it here. So this will gonna be 3, and the y is gonna be positive 1 right here. Let me clean this. So one point will be here. The other point is gonna be, this is 1, this is 3. So it's gonna come right here. And the other one is, lastly, 1/3. If this is 1, then 1/3 is going to be third of it somewhere here. And -1. And this will be last point. Okay. So how the graph is going to go? The graph is going to be like that. Okay, this is gonna be a log x by base 3. Now the whole this graph, we are going to take it and move up by 5. What does that mean? That means this point 0, 1 that we have here, point 0, 1, it's gonna go move up by 1, by 5. So let me see, 1, 2, 3, 4, 5. So I'm going to so if this is 5, so it's gonna be this is, since this was 1 and 0, now we are going to have 5, 1 and 5, yes? So it's going to be 1 and 5, this point. Okay? 1 and 5. And this is going to be our new axis. So, which means 3 and 0, this 3 comma 0 will become 3 and this point, hold on, this point I'm interested, 3 and 1 will become 3 and 6, right? Because y is going to change by 5. So 1 plus 5 is going to be 6. So 3 and I'm moving to 6. This is 5, this will be 6. We understand, right? What I'm doing. So because I'm moving these 3 points. This one, and now I'm going to move this point. What's the exponent at the point of this one? It's positive 1 and negative 1. So now since I have to shift by 5, y, so negative 1 plus 5, it's going to be the positive 4, right? So it's going to be right here by the same one. It's going to go up and be right here, 4. So which means the graph is going to go like this. Oops, not good. So it's going to go parallel to original one. Okay? And this is log x by base 3 and plus 5. Okay. So domain, let's also identify domain again. There is no what's the domain it's gonna be. So practically everything is switching x with y. If you switch, then instead of exponential graph, you will get logarithmic graph. So because in the case of exponential graph, we had domain all the way from negative infinity to positive infinity. Then in this case range is going to be from negative infinity to positive infinity. Why? Because look here, this color, this is gonna keep going down, right, to negative infinity, and here is running to positive infinity, this range, right? But it's a different story. X, it's starting from 0, right? It's only positive x, from 0 to positive x, right? Therefore, the domain is going to be from 0 to positive infinity. Okay, question number 12. So f of x is equal log x by base 4. So we already know how it's going to look like. Let's build it. So x and log x by base 4. So again, let me rewrite it. It's 2 by base 4. Since I have base 4, then first I'm taking 1, and then I will take 4, and then I will take 1 over 4. So when it's 1, so my the x is 1, then log 1 by base 4, it's going to be equal 0, right? So 4 to power 0 is equal 1. And then if I have it 4, it's going to be equal 1. And if I have 1/4, it's going to be equal negative 1. Yes? Okay. So the graph is going to look like so 1 and 0. Every single logarithmic graph is going to go through 1 and 0. And then we have positive 4, 1, 2, 3, 4, positive 4, and 1. Oh, I'm sorry. My x is 4. So this is 1, this is 2, this is 3, this is 4. Okay, 4 and 1. Yeah, I was wondering why it went that high. Logarithmic function never doesn't go that high unless the basis, it's the basis fraction. Okay, and lastly, x is 1/4. And we get negative 1, this point. And so the graph is going to go like this. So we have log x by base 4. Question number 13. We have y is equal log x minus 1 by base 2. X minus 1 by base 2. Okay. Here we have change of x. Remember what I said, change of x always gonna go opposite direction. So let me draw this graph. So first I'm going to graph logarithm x by base 2. So this is 1. By base 2, it's gonna go something like that. The smaller the base, the higher logarithm is going. Okay, so but I need, this is logarithm x by base 2, but we need x minus 1, so this 1 and 0 gonna shift to by 1, right, which gonna come to here. So it's going to be 2 and 0, right? So this graph, it's going to come the same way. And then go parallel. So this is going to be, while this point is 2 and 0, so the graph is going to be log x minus 1 by base 2. Okay? Question number 14. We have, okay, f of x is equal log, it's very good, x minus 1, same graph, but by base 3. By base 3. Okay? So, what is it going to look like, the graph? It's gonna go like this. Okay. All right. So logarithm x by base 3. So let me build by point. So we are taking 1, which is going to be 0. We are taking 3, it's going to be 1. We are taking 1/3, it's going to be -1. Yes? So if this is 1 and 0, 1 point, and then 2, 3, 3 and 1, and third point is going to be 1/3 and -1. So this graph is going to go like this. This is logarithm x by base 3. Now, for logarithm x minus 1, it's 1 and 0 point, this point 1 and 0. Gonna move to 2 and 0, right? Right here. 2 and 0. So, which means also this y-axis is gonna move by 1 here. This will be our new one, new y. And the graph is gonna go, so points, let me calculate all these 3 points. So my x is changing by +1, which means this point, that is what? 1/3 and -1. It's gonna become 1/3 plus 2. 2 let me see. 2 and 0 and it's gonna be 1/3 plus 1. It's gonna be 1 and 1/3, so it's gonna go 1 and 1/3 somewhere here. Yes, and y is gonna stay same, -1. How did I get 1 and 1/3? So my x is 1/3 and I'm shifting by +1, right? So 1 plus 1/3. And this is going to be my next point. And last point, this one, which coordinate of this one was how much? This is 3 and 1. So 3 plus 1, we're changing x, right? It's going to be 4 and 1. So 1, 2, this is 3. Let me clean this. This is 2. And this is 3. Let me zoom it so you can see better. So this is 0.2. And this is 3. So 3, 1, it's going to be 4 and 1. Like this. So 1 is this point here. And then the other one is going to be this point and then this point. So the graph is going to go and this is logarithm x by base 3 minus 1. So the bottom line is, once you have all these points, 1 and 3 and 1/3, so for x minus 1, let me show you, it's not difficult. Logarithm x minus 1 by base 3. So the x is going to be, the coordinate of x is going to be, I'm going to move every single coordinate by +1. It's going to be 2 and 0. It's going to be 4 and 1. It's going to be 1 and 1/3, comma, -1. These 3 points. Because x is changing by 1. Okay, next one. Log 4. Look at that. The logarithm x by base 2, it's going higher. See? It's going higher than 3, right? This is 3. It's going a little bit lower, which means 4 is going to be more even lower. So, which means the higher is the base, the closer it gets to x-axis. Number 15. F of x is equal logarithm x by base. Oh, okay. It wants x minus 2 by base 4 and plus 3. Okay, let's do it. So what do we have here? We are horizontal shifting, which is going to be horizontal shifting.